I want to have a look at gases. I want to look at gas pressure compared with temperature. I want to have a look at gas pressure compared with volume, and I want to have a look at something called Brownian motion. So I've got a few experiments to have a look at. It's taken us a long time to try and get them all working, but hopefully we'll be able to see what goes on, how pressure is affected when temperature changes and when the volume changes. So let's go and have a look at some of these experiments. So I've got a variety of experiments here we're going to have a look at. I've got the Boyles Law equipment. I've got an experiment here ready to have a look at Brownian motion. And I've also got this one here, which is the first one I want to have a look at, which is to look at the difference in pressure and temperature. So I've got a little container here. It contains about 40 centimeters of air inside this cylinder, plus the other in this bit. And what we're going to do is we're going to push this plunger down. We're going to decrease here the volume, and we're going to have a look and see what happens to the temperature. So I've got a pressure sensor connected here, and I've got a temperature sensor connected here, and we've got this set up in some software. Let's have a look. Right, let's have a look. What I've got is a pressure sensor connected, temperature, and then I've got the pressure and time graph, and I've got a temperature and time graph so we can see what happens. So let's set these recording, and we've got a temperature, we've got a pressure which is at 100 at the moment, and what I'm going to do is I'm going to push this down. So ready, here we go. Let's push this one down, and what Paul's going to do is switch over to the computer. Up, and then it's dropped down. Now what I'm going to do is press 1 for me. I'm going to release this, and as I release it we're going to see what happens. So I'm going to release it now, and the other way, and what we should see is a temperature fall. So let's just stop the experiment here, and what we can see is I've got pressure of 100. This is at 40 centimeter cubed on the little machine. Let's bring it over so you can see in more detail. So here's the equipment. It's got a temperature sensor and a pressure sensor. We've got 40 of air, and when I push that down to 20, then we saw that the volume went down, so the pressure in fact went from 200 to 400. Let's just increase this scale a little bit. So it actually made 220 when I pushed it down, and it stayed then steadily for the rest. And then when I released it, the pressure went back to 100. At the same time, the temperature skyrocketed here to about 42. Let's have a look and see what it actually did do. So that's before we started, and you can see 34, 42, it went up to 42.5 before falling down fairly rapidly back to 0. And then at around about 45 seconds, temperature was quite happily at about 27. Then I released it and the temperature dropped dramatically down to about 14.2 Celsius before gradually returning back to normal. So we've got some idea about pressure and temperature. Now what I'm doing here is I'm changing the volume, and as I change the volume by pushing down here, I'm increasing the pressure, and then it returns to normal. Let's try this again, but this time I'm only going to push it down. I'm at 40. I'm only going to push it down to 30, and let's see what happens. So we're all set, ready to go. I've got the experiment recording, and let's have a look and see what happens here. I'm just going to push it down just to 30. And I'm going to release it, and it goes back to 40. Looking on volume change, and we also got a temperature change. Not as much as before, only up to here I can see about 35, and we allowed it to return nearly to normal before I put it back and the temperature dropped before returning back to normal. So gas pressure and temperature. As I change the pressure, which I'm doing by increasing or decreasing the volume, something happens. So let's try this again. This time I'm going to decrease the pressure by making the volume larger. So we're going to take this from 40 up to 60. Let's have a look. We can predict the temperature should drop. Experiment's recording. We can see, hopefully, there it's recording. Right, press the wrong button. And let's have a look. I'm going to pull this out now till we get to 60. And Paul will switch over. Ready? Up we come to 60. Paul will show you what's happening. And we can see the pressure has decreased and the temperature has dropped. Let's release this now back to 40, which I did slower than I anticipated because I wasn't looking. Temperature returns, push down hard to 20, the temperature rose and then gradually falls, as does the pressure slightly, because when I push it down I get a slight increase, and then I can release and it returns back to 40. So we can see quite happily here pressure decreasing. That's me not holding it well enough, releasing, and we can see that temperature is changing according to the pressure. Now we can see this by doing various other exciting experiments. One of the really exciting experiments to try is to take a sealed can, like baked beans or something like that, and simply heat it. Don't open the tin, just heat it. And the pressure increases and increases and increases until the tin fails and it explodes. People get covered in boiling baked beans and they lose eyes and a few other bits and pieces. But it's a good experiment and worthwhile. You know, I like to try and find the real nuisance in the class and make them stand there and have a go at doing it, and then we only have to find another nuisance afterwards. No, not really. Right, so a bit too dangerous, that one, to do because of the risks of the damage it's actually going to cause. So no, don't try that one at home. I'm not going to try that one here. Done it before, it's too dangerous. Now, what we've got is volume and temperature. Well, let's see what else can happen with some of this, and we can try perhaps another experiment out, and this one works quite well. So I'm going to take on my software, I'm going to go for a new experiment, file, new experiment, and I won't bother to keep that. And what we're going to choose this time, I don't particularly want to upgrade my firmware at the moment, is I've got a wireless pressure sensor. So let's have a look and see what we can do with this one. Now, what I'm going to do with my wireless pressure sensor is, let's just call up a graph we can record here, just the pressure. And we'll leave it like that because I'm going to have a look at a different experiment. Now, in this experiment, what I'm going to do is I'm going to take my little wireless pressure sensor and I'm going to put that into a balloon. And I've got a large balloon here. And the hard bit about this is getting the thing in without switching the switch off. This does fit in, just with a little bit of difficulty. Getting it out can be a lot simpler. Because in that case all we need to do is burst the balloon. There we go. And there, after a considerable amount of effort, I've got the wireless sensor, pressure sensor inside here, and what we're going to do is we're going to inflate the balloon, and we're going to see what happens here. So as I inflate the balloon, quite a big thing to blow up. Right, we got the balloon. So let's see what happens when we change this. So I've got my balloon, I've got my sensor in it, and let's have a look and see what happens to the pressure. So let's have a look. So I'm going to record. We've got some sort of pressure in here, and I'm going to let the air out. Well, I'm unimpressed with that one. Let's just move this up, and we'll change the scale. And there we can see something happening. So I've got some pressure change. I've got from about 101 to 103. So we were at 103 when I blew it up, 101 when it's down. So let's try that one again, but this time I'm going to try and blow it up. So I've got my balloon, I'm ready to blow it up. I'm going to set the recorder going, and I'm going to get you to try and watch what happens on the screen while I blow. Right. All right. The balloon is remarkably difficult here to blow up because it's got such a large hole. Here we go. One more go. And that's about as much pressure as I can get in. We've made the balloon quite large. It's gone up to, as we can see, only 103 pascals. And if I release the air quickly, let's see what happens. And there we've got the pressure suddenly dropping, and we're returning back to normal. Quite a hard experiment to do, that one, because this is so big to try and blow up. It keeps sort of collapsing. But with my lungs, I can't manage to get a very high pressure. For that, we're going to have to try a different experiment. And we're going to have a look at the experiment here. We're trying to change gas pressure and volume. And a better way of doing that is to use a specific piece of apparatus. So let's go over and have a look at this one. Now this piece of apparatus is a better version of what I've just been trying to do. This is basically called Boyles Law, and we'll have a go at trying to do this one. I was going to try and see if I could quickly turn my sensor off. Maybe not. Alright, let's have a go and see what we've got here. This took us a long time to get set up. It had a set for a nice bicycle pump, and obviously it's made for a different style bicycle pump than available in the UK, but we've now managed, having taken the entire valve assembly off. There is our offending critter that took us about an hour and a half to try and get this to work. We've removed it. We've put on a foot pump here, which is just an old car foot pump, and we've got here a pressure gauge, and we've got here some liquid in a tube. And as I increase the pressure, so here the liquid will be forced up the tube. And can't quite do this experiment as automatically as before, but what we can do is we can record some pressures and the numbers. So let's start with this. At the moment I've got a pressure of 0, and this is all going to be released. There's my pressure release valve. I'm going to tighten it up, otherwise we won't get very far. 0 on here, and this is set to 49. So I've got a 0 pressure and we've got 49. Let's put a little bit of air in here. I've taken this now to 9, and at 9 we've got 32. So here we're measuring in either kilograms per centimetre squared or pounds per square inch. I was looking on the pounds per square inch rather than the other one. Pressure has fallen slightly. You'll see that it is going down because basically I can't maintain this vacuum terribly well. So I can do it in kilograms per centimetre squared just as easily. It's just not as easy to read. So we're starting off again at 49. Let's turn that up really tight, and let's put some pressure in. And that is at 10. It's going down very slightly, and that's going to be about 0.7. And to get it back to where it was, I can put a bit more in. So let's wait till we get down to 1. This is 1 kilogram, and it's now, and that's 25. So if I do at 0, this is 1 kilogram per centimetre squared. Let's put a little bit more in. Let's see if I can get this up a little bit higher. And at 2 we're at about 17. I can try that one again. About 18, 17 and a half. Too high, coming down at this point now. Yeah, about 17. So I can get to 2 kilograms per centimetre squared, and we can get to about 17. and you'll see the pressure does fall. This is because basically this equipment leaks very slightly, probably due to using a grotty pump here. Let's take it up to about, well, let's try 1.5. Let's try see if I can get to 1.5, 1.5, and that at 1.5 is about 20.5. So we're not getting any consistent results here. So let's start again and we'll see if we can get this going. Right, so it's gone back to normal. I'm just leaving it for a moment to sort of settle. And here we're on 50. So this time 0 is 50. Let's tighten it up. We'll have a look. So we can take to about just over 0.5, about 0.6. Still falling, unfortunately. I do lose some air. Coming down to about 0.5 here at about 33. One is 25. 1.5 at 20. 2 is set to 17. 2.5 at 15. And if I can get this up to 3, we get up to about 13. There we are, just about 13. So as I'm increasing the pressure, so the volume is decreasing. We're going to do it one last time. This time we're going to record all the values, see if we can work out anything. So I'm going to try and get my values for 0.5. This is measuring kilograms centimetre squared. 1, 1.5, 2, 2.5, and maybe 3. So we've gone from 50 to 0.5, coming here. Back there is about 30, 31. Take it up to 1. There's our 25. 1.5 is about 20. There's 2 at 17. We've got 2.5. And that's at 15. And finally, let's see if we can get to 3. And that's about 13. And I'll release the air. And it falls down to about, looking there, 50 again. I'm sorry I'm putting my head down in the way, but I'm trying to also get level. Okay, let's have a look at this experiment. So we've got some fairly cursory figures here. We've got not as well done as I would like. This is the measurement in kilograms per centimetre squared, and this is like arbitrary units. And we remember on this runs this way, where we've got 50 down the bottom and we'll have 0 at the top. And we're filling this with this red liquid, as this is connected to some sort of gauge, and this is our arbitrary scale. Our arbitrary scale here isn't quite as arbitrary as you think, because this is volume. And we're seeing now how the pressure decreases the volume. So we started off with a volume of 50. Just by increasing the pressure from 0 to 0.5, our volume has decreased quite dramatically. If we try and plot this as a graph, we can get some nice figures. And what I'm going to do is I'm going to plot this as a graph. Now plot this as a graph is really quite easy. And what I'm just going to do is get the graph paper out and have a go at doing this. I could cheat and use programs like Excel to do this, and in fact it's a lot easier using products like that to do the changes. Now what we're going to decide is, when we're drawing a graph like this, which way we want to do it. And I'm going to put the pressure on this side, the thing that I am changing, and we're going to have the volume on the bottom. And what I want to do is go from 0, 10, 20, 20, 30, 40, 50. My pressure we're going to change, and my pressure, which I didn't measure in pascals but in kilogram squared, we're going to go from 0, 0.5, 1, 1.5, 2, 2.5 and 3. So let's have a look at this data. I've got the data here, and we'll try and measure. So at a pressure of 0, we've got a volume of 50. When we went to 0.5, it went to 31. When we went to 1, it went to 25. When we've got to 1.5, it went to 20. When we went to 2, it came down to 17. 2.5, we went to 15, and finally at 3 we went to 13. And that gives us our little graph that we can try and draw in our values. Maybe I really ought to have got a value of about 0.25 down here. It would have given a better idea of where this graph was actually going, because my point between here and here is a little bit woolly, so I can very easily sketch the graph of that. and that one's a little bit less obvious what's happening. This type of graph is giving us something that is here inversely proportional. So here, an inversely proportional relationship between volume and pressure. So as the pressure increases, the volume then is decreasing. We can look at some values about this because there is some sort of relationship. And our relationship is that pressure times the volume basically equals some sort of constant. When we do that, our pressure is typically measured in pascals. When we looked at the first experiment, I was measuring this pressure, as you can see on the graph label there or on the table. We're measuring in kilopascals. For measuring this experiment, I've got kilograms per centimetre squared. It's just the different units that the dials were using. So not terribly helpful really on that. But we have what we have. So this gauge for this other experiment is basically American, and they like working in pounds per square inch, something we don't tend to use so much in this country. Certainly not when we're doing science. There's our idea then. Gas pressure changes, and it changes as we increase the pressure, so the volume decreases. And the other one we've looked at is that with temperature, that as we increase the pressure, so the temperature also rises. So there's another one that we can have, and that gives us another relationship, and that is that pressure times temperature is also going to give us some sort of constant. So this causes a few problems for general life, and there is a relationship between these things, and there is something which I know is called the Ideal Gas Law, and this looks at relationships between all of these things. And if we take it, basically we get this idea that pressure and volume divided by temperature here equals some sort of constant. And this is what we use to try and measure things. So this is our relationship. We've discovered that pressure times the volume is a constant, and in fact pressure times temperature, or in fact better, pressure divided by temperature is a constant. And putting those together, we can get this relationship here of something with the ideal gas law. The ideal gas law is about ideal gases. An ideal gas is the perfect gas. Of course, gases are anything but perfect. I want to look at a third experiment now. This one, my record on this one is not good. So we're going to have a go and see what we can do with this experiment. And we're going to have a look at seeing if we can see the air. This was first done by a gentleman called Brown. It was a botanist called Robert Brown, and in about 1785, just looked it up, he did an experiment and he noticed that you could see not air but smoke particles move. Air particles are way too small to see. They're atoms. They're flying around at high speed, but we can't see them. So Robert Brown came up with an idea of trying to put some gas, some smoke, into a little bottle, and to see if he could actually see them being buffeted around. So the idea is that we've got a very large soot particle, and it's being banged, jostled by some other molecules. So here is my particle of soot. This is my bit of smoke, and this is collided with by an atom moving at high speed, and this causes this soot particle to move very small amount. But another one might come along, and then it moves another small amount. Well, let's see if we can see this working. I don't make any promises because this doesn't normally work when I do it, but let's have a look and see if we can get it to go. If it does work, you'll be as surprised as I am. We'll move the what's called Boyles Law apparatus out of the way. And we'll bring in now a microscope, and what we're going to do is I'm going to cheat and I'm going to look down the microscope, and if it works then we're going to plug the camera into the top of the microscope. So we can, in fact, with this microscope, just take the binocular top off and I can position the camera over the top. We'll plug it in and then you should be able to see what happens. I'm not that confident, so we're going to see what we can do. Okay, let's have a look at the rest of this equipment. What I've got here is a bottle which we're going to try and fill with some smoke. The smoke, I can then squeeze this and hopefully we're going to get some into this tiny little tube down here. Now this little tube is a little tube of plastic, so we should be able to see what's going on. It's got a seal at the bottom, so hopefully we can get some gas in there, and I'm just going to put some sealant on the top. I'm actually using lip balm. That's because we seem to have lost the Vaseline that we were going to use. One of the other reasons we were slow today. Right, so I've got some there. Now on top of that, we're going to blast some smoke through. I'm going to put a small cover slip, and that will go on there. What we can then do is put the light on. That's going to shine light into this tube. We'll put the cover over and then we'll just look down the microscope to see what's going on. So there's the experiment. We're having a very bad day for interruptions on the phone, which is everyone that's just then rings up and then hangs up. So I've got here a simple light LED. It goes through a lens and hopefully focuses it on so we can see. There's the experiment in theory. Let's see what happens in practice. Now, what I'm going to do is I've got a piece of string. String's pretty good at burning and not making quite a lot of smoke. So what I'm going to do is I'm going to set fire to this. There, burning nicely. We're then going to take that and put it in here. And you can see hopefully we've got some smoke coming out. And if I put this over the top and onto the microscope, we had a lot of problems trying to fit this in before we can get that in. Now we're going to just see if we can get some smoke in there. I don't think we did, so let's see if I can have one more go at trying to get some smoke in there. Got my bottle ready. I've got my string burning. And if I look down here, I'm going to try and see if I can see any smoke particles. Well, my answer is I think no, but we're going to try one more trick. We will try the camera on top. I'll just put the camera on. And I can say quite happily that I don't think I can see anything down there. That is my view down there, and I can't see any little particles of smoke going. We're just going to try putting one more time in. I'll go in. Right, let's try and put a bit of smoke in there. And yeah, I can see that that one hasn't managed to work. I've moved it too much. Right, so there's the setup. But I came prepared. You see, what I've got is I've got another little way of looking at that same thing. So what I've got is a failure, I'm afraid, on this camera. We did try to get it to work, but alas, no luck. I haven't had much luck with this experiment. I will just put the microscope back. For a moment I thought I saw something. Now, the big problem with this, it does put this equipment, the way it's set up, it puts smoke in, but then it tends to suck it back out again, and I don't think it's really the best design that I've ever seen for a smoke cell. But let's try something else. And what I've got is a way of having a look at what atoms do. And what I've got is a simulation of this, which you can try at home. And all you need for this are really a couple of dice, and I've just stolen my son's dice from his war games, and here we have a simple game that we can have a look at. Now what I've got is a piece of paper with things that I can score either the movement or the direction. The direction that we're going to set up is that 1 is going to be the top, and then we can have 4 being the bottom. We can have 2 and 3 going slightly up and across like this. My fault, I moved it. And then the movement is going to be the number of centimetres. Let's see what happens. All I need for this is a ruler. The black die is going to represent the direction, and the green die will represent the movement. So black says 5, so it's going to go off in this downward direction 6 centimetres. So I'm going to start it at the middle and we're going to move it 6 centimetres. Let's try again. it's now going to move 4 centimetres in a direction 5. Oh, we're very lucky. Gone in the same direction. Two, it's going back where it was going in the opposite direction. Random stuff doesn't help when you're trying to do things. Then we're going to go a 6 and 4, and unfortunately you can see I'm way off my piece of paper already there. I'll fit it just there. And 5 and 2. It's going to move 2 and 5. It seems to want to go in that direction. So what we normally manage to do on one of these objects is we manage to get something really equivalent to this, and this we call the random walk. I'll show it to you a bit easier on this camera.
So that is what I was predicting. And in fact, this is what I got. It's wanting to go off in this particular direction. If we do enough, we can see this random walk work perhaps a little bit better. But we get this random motion, and you can do that with two dice, and you can see this happening. So this is observing this random motion of gas particles pushing on smoke particles, and I just don't seem to have an awful lot of luck trying to set this up. My personal opinion is the machine is just not really up to it and doesn't work. So we've looked at gas pressure and temperature, we looked at Brownian motion, and then we've looked at gas pressure and volume, and seen that there is this relationship with basically having the gas law, as it's called, the ideal gas law, which is P times V over T is some sort of constant. We do find that there is some real relationship to this, and for A level we discover that we can work out that pressure times volume is the number of moles times something called the gas constant times temperature. PV equals nRT. So that gives us some ideas here about temperature, about pressure, and about the nature of gases. If you like this, please subscribe, and I will see you again next week when we'll have a look at some more GCSE physics topic by topic.